All right, we looked at the unit circle briefly yesterday, and now we're going to finish the rest of this. So I would encourage you as you go through, try to get in that habit of doing this every day as we go through this, and it will help build that. So when I'm looking at this, I'm like, okay, that's 1, 2, 3, 1, 2, 3, square root, square root, square root, square root, square root, all over 2. And we get that. So those are our ordered pairs. I should know that this is 30, 45, 60. That's also pi over 6, pi over 4, and pi over 3. Let's not forget about our axes marks. This is 1, that's 0. This is 0, that's 1, that's 90, and pi over 2. This is 0, 360, and we'll say 2 pi. Okay, so we should be able to do that. You will not have that available on your test. You can write that down when you first get your test, though. So what I want you to do now is, if you're watching this video for the first time, I want you to, before you fill out anything, because I don't want you to have to erase it or whatever, I want you to work together, and I'm going to probably give you all about 10 minutes in class. Try to fill out the rest of the unit circle with the degrees at least and the ordered pairs all the way around. If you need to do it on a scratch sheet and just kind of do a rough draft of it, great. See if you can do that, and then we'll transfer that over once we have the final thing here in a second. Use your cutout triangles and patterns to help. That's what they're there for. So just kind of think about those as a puzzle and line them up, and then just fill in the x, y values. But pay attention to the signs of x and y in the different quadrants that we're in. When you're finished, well, we'll talk about this. So that's given time. I'm going to kind of explain why this stuff is the way it is. So we're going to get the ordered pairs out of the way. So if I look at the horizontal distance from the center to each one of these triangles, that's talking about the x distance. Like let's look at this value, for instance. The distance between the origin and the x value distance between the center to where that perpendicular side goes up is square root of 3 over 2. And the same distance is over here as well. And the same distance from there to there is that, and the same distance. These all have the same horizontal distance. So they should all be a distance of the square root of 3 over 2 from the origin. So every single one of these reference triangles, here's our bow tie again, at 30 degrees should be square root of 3 over 2. The y distance is the same as well. If we look at our reference triangle in 30 degrees, that y value is 1/2. So the distance should all be 1/2 from the x-axis. So we need to consider the sign of the x and y in each quadrant. So in quadrant 2, x is negative, y is positive. In quadrant 3, x and y are both negative. In quadrant 4, x is positive, y is negative. So we get the same ordered pair going along through those. We can do that same type of logic for every single one of these in all of these different ordered pairs. So the reason why we want to focus on memorizing quadrant 1 is we can memorize quadrant 1 and then just think a little bit about signs. The signs around the quadrants to figure out what those values are. We do need to also make sure that we know our angles. So we notice the pattern here, right? We go from 30 degrees, then 15 degrees gives us 45, 15 degrees gives us 60, and then 30 degrees gives us 90. So if I'm at 90 degrees and I rotate 30 degrees from that, that would give me 120. Another 15 degrees would be 135, 150, so on and so forth. 210, 225, 240, 300, 315, 330, and then all the way around would be 360. I didn't do my animations, I don't think, very well. Okay, so talking about the radians around the unit circle, these should have popped up in a different area, but to figure out the radians, here's kind of a shortcut for that. They're all, in every single quadrant, the reference angle and radians are going to match the denominators. So when I see this triangle over here, that's the same thing as this, same thing as this. That's the reference angle is going to be pi over 6. So our denominators for all of these other quadrants are also going to have a 6 in them. And here's the way I like to think about it. So that's pi over 6 in quadrant 1, and quadrant 2, like going all the way around from here to 5 pi over 6, the reference angle is pi over 6. But to figure out that that is pi over 6, think about in quadrant 2, everything in quadrant 2 is almost 1. Like 5 divided by 6. If the numerator was 6, that would be 1. If the 3 pi over 4, if the numerator is 4, that would be like just 1. If the numerator for 2 pi over 3, if that was a 3 instead of a 2, 3 over 3 is 1. So quadrant 2, all of your fractions are going to be almost 1. And then in quadrant 3, all of your fractions that we see are going to have the same denominator as quadrant 1's, but they're all going to be 1 more than 1. So more than 1 over here, like 7 over 6 is more than 1. It's 1 more than 1. 5 over 4 is 1 more than 1. 4 over 3 is 1 more than 1. Right? So quadrant 3 is more than 1. Quadrant 4 is 1 less than 2. It's almost 2. Like 6 goes into 11 almost 2 times. 4 goes into 7 almost 2 times. 3 goes into 5 almost 2 times. So we can remember those things. Our denominator should be 6, 4, 3. So it's actually greatest to least when you think about it like that. Another way we can think about this, if we don't want to do it that way, is other than the pi over 4's, we can start off at like pi over 6 if we know that much. And then this is 2 pi. Every time we go 30 degrees or 60 degrees, pi over 6 away, it's just, we're just doing this pattern like this. So 2 pi over 6, 3 pi over 6, 4 pi over 6, skip the 45 degree, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. And we just go in order, like 1, 2, 3, all the way around, skipping the 45 degrees. But if we simplify some of those, then we get where we get. Like if I simplify 2 pi over 3, 2 pi over 6, sorry, that gives me pi over 3. So if I simplify 3 pi over 6, that's pi over 2, and so on and so forth. So we can also think about it that way as well. Or you can just think about, like, we need to focus on what quadrant we're in a lot. So probably the quickest thing is to figure out, are we almost 1, more than 1, or almost 2? And this is our entire unit circle. So this is what your unit circle should look like when you're done. It should look like this. So the entire unit circle is made up of these ordered pairs: 0, 1, 1/2, square roots of 2 over 2, and square roots of 3 over 2. Those are all along my special triangles and then my axes ordered pairs. So you need to know how to memorize quadrant 1 when determining the values in quadrants 2 through 4. We need to consider the following: that the given angle and the reference angle will have the same ordered pairs but different signs. Depending on the quadrant of the given angle will depend on whether x and y values are positive or negative. And we also need to know that the sine is the y value and cosine is the x value and tangent is y over x. So we're going to look at a mnemonic device that will hopefully help us remember the signs of the trig functions in each quadrant of the unit circle. And it works like this. So the signs of the trig functions in quadrant 1. X and y are both positive. So in quadrant 1, everything is positive. So all functions are positive in quadrant 1. So what I'm going to put here is A for all. All of those are positive. In quadrant 2, we know that x is negative and y is positive. So if sine is y and cosine is x, we're going to, our mnemonic device to help us do this, and this is just kind of showing why this is what it is. Sine is the only thing positive in quadrant 2. So we're going to write S, or students. The mnemonic device is all students take calculus, starting from quadrant 1, going through 2, 3, and 4. So that S for students is telling us that S stands for sine. Sine's the only thing positive. In quadrant 3, all students take. so t. So in quadrant 3, sine and cosine or x and y are both negative. And if we divide a negative by a negative, that's a positive. So the third quadrant, tangent is the only thing that's positive. And so all students take calculus. So all of these A, S, T, C that we're about to write is talking about which one's positive. The other two will be negative. So in quadrant 4, all students take calculus. Here, x is positive, which is cosine. Y is negative. Positive and a negative divided by are negative. So in quadrant 4, cosine's the only thing that's positive. So we have this all students take calculus divided up in those quadrants, and this is to tell us which ones are positive. A stands for all of them, S stands for sine, T stands for tangent, C stands for cosine. So what I would get in the habit of doing as we're going through these is drawing this out real quick, really fast, and then also quadrant 1. Okay, so I would encourage you, redraw this out again. Get comfortable with that. So we're going to find the sine of 120 degrees. So the first thing I'm going to do is I'm going to draw this back to what my reference angle is. So remember, reference angle is how far away from the x-axis I'm in. I'm not in quadrant 1 because that's between 0 and 90 degrees. This should be in quadrant 2. So I'm in quadrant 2, and I need to find out how far away from the x-axis or 180 degrees I am. So what quadrant is 120? It's in quadrant 2. 120 is 60 degrees away from the x-axis. So now if I think about this, and I've already had this done, like I can often like say, okay, that's 60, 45, 30. Here I know that this is 1, and that's square root of 3 over 2, because in my mind I'm going 1, 2, 3, 1, 2, 3. And after you kind of see these 100 times, you kind of get used to that. But I'm looking for this line right here, and I need to figure out the sine, which is my y value. So the sine of this, let me get rid of my doodle. The sine of this is square root of 3 over 2. And since I'm in quadrant 2, sine is positive. So I'm thinking, okay, what is the ordered pair there? And then what is the sign? Is it positive or negative? And in quadrant 2, my original quadrant of 120 degrees, sine is positive. So it's just square root of 3 over 2. So these are non-calculator questions, by the way. Like, you will not have a calculator for this. So I'm going to give you something like this, and you'll have to say square root of 3 over 2. Cosine of 225 degrees, that should be in the third quadrant, where both sine and cosine are negative. How far away from the x-axis am I? I'm 45 degrees. That is my root 2 over 2 for 45 degrees. And since I'm in quadrant 3, it has to be negative. Tangent of 330 degrees is in quadrant 4. I'm 30 degrees away from the x-axis, so my reference angle is 30 degrees. I'm going to trace this back to quadrant 1 that I should have filled out on my paper somewhere, so I don't have to think about everything all at once. I do know that all students take calculus, so cosine's the only thing positive in quadrant 4, so my answer should be negative once I figure out what that is. So that's a 30-degree reference angle, so I'm 1, 2, 3, 1, 2, 3. So 1/2 divided by square root of 3 over 2 is what I'm going to be doing, which would be this. Those would cancel. I'm going to rationalize my denominators, multiply by the square root of 3 over 3 to give me that. In quadrant 4, tangent is negative. All right, tangent of 5 pi over 6, that is almost 1. 6 goes into 5 almost 1 time. So that should be in quadrant 2. So that tells me that my reference angle is just pi over 6. It's always going to be, just take away that what's number is in front of the numerator. That is just pi over 6. Pi over 6 is the very first one that we have. The very first angle, the 30-degree mark. So if it's tangent, it's 1, 2, 3. So 3 is going to be the second thing, and then 1/2. So 1/2 divided by square root of 3 over 2. If I'm in quadrant 2, tangent is going to be negative because all student stands for sine. So I'm going to write this out. 1/2 divided by square root of 3 over 2. simplify those, and I get square roots of 3 over 3 again. But it's going to be negative because quadrant 2 is sine is the only thing positive. All right, 5 pi over 3. 3 goes into 5 more than once, but it goes in almost twice. So almost 2 here, because if 5 was 6, then it would go into it 2 times. So where is that? That's in quadrant 4. So I should be in quadrant 4. I'm looking for sine. All students take calculus. Cosine's the only thing positive in quadrant 4. So my answer should be negative. If we want to go ahead and write a negative so we don't forget, let's go ahead and do that while we're thinking about it. So we're in quadrant 4. It's going to be negative. My reference angle is just going to match the same denominator, pi over 3. So that's my third line from the x-axis, my 60-degree mark. So 1, 2, 3, 1. Oh, so I'm looking for sine. So 1, 2, 3, 1, 2, 3. So that is my square roots of 3 over 2. And we're negative, and since we're talking about sine. All right, 7 pi over 6. 6 goes into 7 more than once, but not quite twice, or not really close to 2 times, but a little more than 1. So we're more than 1 here. That means we're in quadrant 3. Cosine and sine are both negative. Since we're asking for cosine, our answer should be negative. I like to maybe go ahead and put that on there so I don't forget. It's going to be negative. Pi over 6 is my reference angle. That's the first terminal side that we have on the unit circle. So 1, 2, 3, that's square roots of 3 over 2, or negative square roots of 3 over 2. So once again, pi over 6 is our reference angle. That's this one. Cosine is our x. And in quadrant 3, cosine is negative. Negative 225 degrees is just telling us a different rotation. We can go ahead and make a coterminal angle and just add 360 to that and forget about that. That's 135 degrees, which is in quadrant 2. How far away from the x-axis is that angle? That is 45 degrees. That is my root 2 over 2 mark. And in quadrant 2, all students, sine is the only one that's positive. So this should be a negative root 2 over 2. Negative pi over 6. I can add 2 pi to that if I wanted to, or if I can just recognize this is going down to quadrant 4. It's like pi over 6 is going counterclockwise, negative pi over 6 is going clockwise. So I should be in quadrant 4, or I can add 2 pi to that and get 11 pi over 6. That is almost 2, right? 6 goes into 11 almost 2 times. That's in quadrant 4. My reference angle is how far away from 2 pi I am, which would be just pi over 6. Just ignore the numerator and write the pi over 6. This is my first terminal side on the unit circle, and in quadrant 4, tangent is all students take calculus. Cosine's the only thing positive in quadrant 4, so my answer is going to be negative here. And at pi over 6, I have 1, 2, 3, 1, so 1/2 divided by square root of 3 over 2. So I'm looking at y divided by x for this guy. So that divided by that. And I get square roots of 3 over 3. Negative square roots of 3 over 3. And now it's a matter of practicing this. So this is important that we get all of this practice done and that you're very comfortable with this moving forward. Good luck. Make sure you ask questions.